In this demo, we will understand how exactly to interface potentiometer with Arduino. The setup is very simple and follow our instructions as we have given during the theoretical explanation about the connections to interface the Arduino Uno with potentiometer. The potentiometer we have chosen here is 4.7K potentiometer, and a potentiometer is nothing but a variable resistor. Remember it is a variable resistor. Once the connections are all made, please go ahead with the Arduino IDE with our code available there. Select the appropriate COM port from the tools option. Select the COM port properly, and once it is all done, you are all set to go. Upload the code. The code gets uploaded after compilation, and once it is done, please open the serial monitor for you to visualize the output. Now you can see that the initial potentiometer values are presented as 930, 931. It settles down slowly and it is mostly 930. Now you can see that I'm having a screwdriver in hand and I'm going to rotate the potentiometer in clockwise direction. As I tune it in the clockwise direction, you can see that the values are getting decremented step by step, and that's what you are visualizing in front of you. It has come to 880 now, and when I keep rotating it in the clockwise direction, the value keeps decreasing. And that's what is the exercise that we are doing. Now, I am incrementing it. I mean, I'm rotating it in the anti-clockwise direction, and you can see that the values are incrementing gradually. That is it. You have interfaced potentiometer with Arduino Uno. In this tutorial, we'll clearly understand how do we control a servo motor with a potentiometer. You should make the connections as we have presented you during the theoretical session. Just follow all the guidelines and do the interfacing so that the setup will be fully functional. You can see that we have the potentiometer and servo motor clearly interfaced, and you can do the same with the guidelines provided. Once it is all set up, you need to go to Arduino IDE where the code is readily available for us to run. Select the appropriate COM port, select COM3 here, and you can upload the code. Uploading happens after compilation as ever, and once it is done, you are all set to see the demo. Now once the uploading is done, you will have to open the serial monitor, and there you can get the output visualized. Now you can see that we are reading the potentiometer value and servo angle. When we tune the potentiometer, the servo motor gets tuned appropriately. You can see that when I tune the potentiometer in anti-clockwise, the angle increases for the servo motor. When I do the clockwise rotation for the potentiometer, you can see that the angle decreases for the servo motor. I'm doing it right now, and you can see that the angle gets decreased. More the movement I give in clockwise, more the angle gets decreased. More the moment I do in anti-clockwise direction, the angle increases. That is it. You have interfaced the potentiometer with servo motor for its controlling. In this exercise, we are going to build a simple messaging application between the smartphone and the Arduino Uno. Please make the connections as we have presented you during the tutorial. Make sure that the 2 and the 4 pins of Arduino are connected to the RX and TX pins of HC05. Similarly, the VCC and ground from the HC05 should be appropriately connected to Arduino. Now you need to understand one point, that the blink rate in the HC05 is faster when there is no pairing has happened. Once the pairing has happened, the blink rate would be slow, and you can observe that. Now once everything is done, please go to the Arduino IDE. Make sure that you select the appropriate COM port. After typing all the necessary codes, upload it. Once you upload, first the compilation happens and then it gets uploaded as usual. Once it is all uploaded, done uploading message flashes on the screen, and please open the serial monitor for you to go ahead with further processing. Also, you need to open your mobile phone where you have installed your terminal app. The Bluetooth terminal app has been installed. Pair it, and once you have paired it, you can see the blink rate will go slow. That's one intimation for you. And whatever message you will have to send to the Arduino, you can type it here as, "Hi, this is my phone." From phone to Arduino Uno, the communication happens right now. You can see that the same message has come to the screen in the serial monitor. Now from the serial monitor to the phone, we can send the message as well. "Hello, this is Arduino," is now sent. You could see that immediately that message gets flashed on the Bluetooth terminal app that we have already installed. That is it. we have constructed a very simple messaging application between the Arduino Uno and your mobile phone. In this tutorial, we will understand how exactly to interface accelerometer with Arduino. You need to follow the step-by-step procedure as we are doing right here. Let's go ahead with the demo. The connections are to be made as we have presented you in the theoretical explanation part. Please follow the connection details meticulously without missing anything to get appreciable results. Now you can see the way we have connected it, and it's the same guidelines which you need to follow, and you can interface the accelerometer with the Arduino and the Arduino to PC. The code which you will have to upload initially is made available here. Make sure that the board is selected appropriately and COM ports are also up and running. Let's upload the code after compilation. It's getting uploaded right now. After compilation, it gets uploaded and you can start the process then. It's done with the uploading. We need to open the serial monitor. We are getting it open right now, and you get the values out here for XYZ axis. But these are not the final values, and this needs definite tuning. How do we tune it? Very simple. We are going to show you that procedure as well, and you got to follow it to get the corresponding and the perfect output. We need to make sure that we are using the map function like what we did with the color sensor interfacing. Now what we are going to do is we are going to note down the values for 0 degrees, and we are going to make a note for 90 degrees as well. For 0 degrees, we get the values as 334, 327 and 397, which is what we have received right now on screen. And for 90 degrees, we will have to make a note right now. I'm keeping the accelerometer in 90 degree, and you are getting the values out there in front. The values are 400, 328 or 329, 330, 331. We make it 331 and we have kept it. This is the actuals that we have received for 0 degree and 90 degree. But are these values right? These values are to be corrected, and these values needs modification. So how do we do it? Very simple. I'm going to let you know the procedure for the same right now. We have to use the map function for X value and mapping this with the X value, comma, the X for 0 degree and X for 90 degree, both are presented, followed by 0 and 90. This will help us in getting the corresponding new value generated. I mean the corresponding corrected value generated. Now the Y value, I'll have to follow the same procedure. 327 and 329 are the data respectively for Y for 0 and 90 degree. You can see that we are entering it, and rest remains the same. Let's go to the Z axis, where Z value has to be updated in the same way with map function, and the values are 397 and 331, and we got to include it. These values are to be mapped for 0 and 90, and that's what is presented in this line with the mapping function. We need to save this as the file, which is an updated file. Let's go ahead and save this as accelerometer_updated. Once we burn this code and get the results out, they are the perfect results that you can see. Now we are compiling it, and we have to burn it into the microcontroller, and the process is complete right now. We are getting the values here as 000 because it is at rest. Now we have to test it by moving it, and we'll get the values appropriately. I'm keeping it at 90, and you can see that the X is 90, Y is 180, 135. It's fluctuating because I'm keeping it at rest right now. And similarly, you can move it at any direction to get the appropriate output. The mapping is the one that helps you in getting the right data. You can move left, right, top, whatever way you want. You will get the XYZ data immediately. We're going to see how exactly the color sensor interfacing can be demonstrated practically. Let's go ahead with the connections first. You can see that the interfacing is all done with the color sensor and Arduino Uno, as I have explained you in the theoretical part. Now let us open the code and go ahead with the process. It's very easy and interesting, so please listen to it carefully. Let's open the color sensor underscore initial .ini file. This is the file which is going to get you the initial values for the color sensor. I am uploading the code right now. The compilation happens initially and then the upload go on. You can see that the uploading is done and we will go ahead with the demo part right now. Let's open the serial monitor and you can see that the RGB values are coming, but these values are not the one that we really want and this is not the correct values. So what do we do? As we explained in the theory section, we need to get it mapped. We are going to use the map function and I'll explain you how exactly this has to be done. We need to take a pure white and a pure black object, take the readings of that, and accordingly you need to map in the code to get this fixed. Let's go ahead with that process and we will get it nicely right now. And you can see the way the color sensor is working and the light, the LEDs on the surface is the one which is going to be very helpful in getting the data. Let's keep a pure white particle, pure white object, and you can see that the values are reflected. You can see that the values are to be noted right now in a notepad 443. This is for pure white. Now let us take a pure black object and I'm keeping it closer and you are getting the reading for it. This reading has to be noted again in the same notepad but under black. Now we need to go with mapping. I mean you need to correct your code accordingly with this values being reflecting there. I'm saving this file for my future reference and this is saved as color sensor.txt. The name of the file is immaterial. You can give any name as you see. Now we need to go with further manipulation and the code editing process has to start right now. I'm going to explain it very neatly and step by step. So please listen to the same and you have to follow the same thing out in the demo. Let me close the serial monitor and you can see that the white, the complete white is all about RGB in equal combo, which is 255, 255, 255. It is called the true value. But what we got 4, 4 and 3. Similarly, black is nothing but 0, 0, 0 for RGB. But what we have got, the sensor values are 33, 35 and 26. So what do we do now? We are going to map it. So frequency equal to, I'm just inserting this line of code after the frequency line. I'm using the map function, map frequency, comma. We need to take the original, I mean the true value and also the values which are received from the sensor. So 4,33 for white and black and that is reflected by 255 and 0 for the true values. The received values are 4,33. The original values are 255 and 0. Similarly, for the next one, it is 4 and 35 for white and black respectively, and it is 255 and 0 for the true values respectively. The final one is going to be 3 and 26, and it remains 255 and 0. Now, let us save this file as the final file, I mean the updated file. We are saving it and this is the file that you need to upload into your system for you to get the correct color being read. That's it. It's very simple. Can we go ahead, compile it and upload it? Yes, I'm doing that right now. The upload happens. Now you should be able to get the perfect value when you test it. We are going to see the same thing right now. For that, we need to take a serial monitor also be opened and let's go ahead and see how exactly things work. You can see that the values now obtained are negative because we do not have any object placed in front of it. Hence, it is throwing negative values. When we keep an object, we'll get right values appropriately reflected. I'm keeping a black object there. You can see that all black is nothing but 0, 0, 0 and we are getting the values appropriately as required and it is all 0, 0, 0. Now for white it is all 255, 255, 255 and you got it very nicely right now. And the final thing is I'm going to test it with a different color. Let's take red. you can see that the red has got 255 and rest 2 G and B have got some intermediary values, which says that this is red dominant, and the G and B values are dependent on the object's color intensity that is placed in front of the sensor. That's it. You can test any object's color like this and the sensor works this way. Thank you. It is time for us to go ahead with the demo for the interfacing of the gyroscope with the Arduino. We'll go ahead step by step with the demonstration process, which you can correlate with the theoretical explanation which we have given. Make the connections as we have already explained you in the tutorial. And please make sure that the connections are VCC and ground from the Arduino to be connected to the VCC and ground of the sensor. Similarly, SDA and SCL to be connected with the SDA and SCL of the sensor, and AD0 to be connected with the ground of Arduino. Do not forget that, and that's a very important step. And the code is already explained. Just copy paste the code here, select the appropriate board, select the COM port properly, and then go ahead with the uploading. The compilation happens and then the uploading proceeds. Once the uploading is all done, you can open your serial monitor to see the values. Now I'm opening the serial monitor and you could see that the values are all arriving for X, Y and Z. The values are almost constant because we have not moved the gyroscope anywhere. And now when we move it, you can see that the values are changing rapidly. This is how it works. And the most important point to remember is keep the gyro in a flat surface, otherwise it might not give you the accurate output. Thank you. In this tutorial, we will understand the working of GSM. It is very interesting and it is very intuitive. When you buy a GSM, you will get certain amount of components given to you along with the purchase. We are going to see one by one and we will explain you what exactly each components are all about. We are using the GSM SIM900A and this is the main component that we are talking about, the GSM unit. The next one is antenna, which is to be connected. This is for the power supply and we are using 12 volt adapter, and this can be 1 amp or 2 amps rating as required. Both will work fine, and make sure that you have the power supply adapter properly. The next most important thing is the SIM card. You can use any SIM card service provider like Vodafone or Airtel, and that's enough, but it should be functional. The next one is very important for us to understand. For sending the AT commands, we need one of the following UART bridges to be used. The UART bridge can be an Arduino or USB to RS232, or it can be a TTL dongle. We are going to interface our GSM unit with all the three one after another, with showing the results immediately following that. And it's going to be interesting and we are going to see that one by one. Let's insert the SIM card first. We are going to do that right now. Please make sure all these processes are followed meticulously. Open this lock, keep the SIM card in, and this has to be the previous version, the bigger one SIM card, not the nano or the micro SIM cards will fit in here. This has to be the bigger SIM card. Keep it appropriately after inserting it correctly in the slot, and you got to lock it. Lock that, and that's it. The connection is over. You have kept the SIM card and the board connected right now. What is the next step to do? We need to connect the antenna and the power cable. Can we do that? Yes, it's interesting and easy to do. Just connect it properly and turn it until it gets tightened. And don't break it by tightening it more. It is very gentle and it can be used nicely. The next one is to give the power supply. The 12 volt adapter has to be connected into the power slot as given, and this side of it is to be connected to the power supply. You can see that I'm connecting it to the plug point and switch it on. Initially, if you see, it will be flickering faster. You can see that it is not yet connected to the net, and so it is flickering faster. It has to be connected to the network and then it will get stabilized, and the flickering would go once in 3 seconds like what you could see right now. If it is not connected, it will be flickering fast. Once it is connected to the network, the flickering rate would be slow. Let's interface using RS232 right now. The RS232 cable is available in front of you and we are going to use it for interfacing our GSM. And let's see how exactly we do it. And one side of it is USB and another side of it is RS232, and we have the slots available with the board GSM and we have connected it properly there, and another side of it should go to your laptop or your PC, and the USB is connected all appropriately. Now, please go to your PC and follow the steps that I'm conveying you right now. It is a step-by-step process. Please go to Device Manager and see if COM ports are all updated properly. COM4 is updated as you have seen. Open TerraTerm and select Serial. There select COM4, which is what we are going to work with, and click OK. Once this is done, 50% of the work is done. Now can we start working with the sending calls? Yes, we are going to make calls right now with the simple process that you have to follow. Just check if things are fine by pressing or issuing AT command. You get OK means things are all okay. Now we are going to use ATD plus 91 is the country code for India, and I'm going to make call to this number, and semicolon is very important there, without which it won't work. Now if you see, you would be getting a call immediately on the phone that I have kept in front of me for the demo purpose, and you got the call. And the number from which the call is made is also displayed. That's the SIM card which we have inserted on the GSM module. The easiest way to use it is this, and the next one is going to be with the TTL to USB. Now we are going to connect the TTL to USB here, and that's going to be very easy as well. Make sure that the connections are all proper by having ground to ground connected and RX to TX and TX to RX respectively at both the ends. And then connect the USB end to the laptop or your PC, and once it is done, it's all easy for us to go ahead and use it further. The procedure is almost the same right now like what we have done in the past. I'm going to go ahead and check if the serial port is all properly enabled. I mean the COM port is all properly enabled, and then I go to TerraTerm, I select serial, and you can see that click it and enable it. Now TerraTerm is all available for us to use. Let's first see what can be done. AT, the board is working fine and we can use it. Now we are going to make calls right now with the same set of commands. There is no change in the commands. ATD plus mobile number, which is prefixed by country code appropriately, and once it is done, it's all pretty easy. You should get a call and complete the command with a semicolon without fail, which is very important. Now you must be getting a call in front like what you got in the previous time. It's all very simple, and the call has come right now, and you could see that the SIM number, the mobile phone number, is also updated properly. I'm cutting the call, and let's go ahead and interface Arduino Uno. This is the third way of doing it. It's slightly complex compared to the previous two methods, but this is easy as well when you compare the rest of the complex interfacing exercises. We need to interface things properly as we have shown you on the circuit diagram. Now make sure that you have got the ground connected properly from the Arduino to the GSM board. The 9 and 10 pins of Arduino should be connected to TX and RX because we are using software serial, and then connect the USB appropriately to the laptop as I'm doing right now. The connections are very important. Please remember we are using software serial. Now what do? We need to open the Arduino IDE and we are going to run the code which is typed and ready for you to use. The code is very simple and it is self-explanatory as well. You can see that we are using software serial library, and the COM port is to be checked if it is enabled proper, and once it is done, you can upload the code after compilation. 9 and 10 are the pins used, and remember they are very important. And you can see that we are going to open the serial monitor after the uploading is done. Make sure the baud rate is selected properly. Both NL and CR are to be clicked. And now in the COM port, we can issue the commands. Issue AT to see if you get OK. That's all, you got OK, which means that things are all perfect. Now we are going to make call with ATD plus 91 is the country code for India. Type the phone number that you want to make the call with and give semicolon as usual. Click enter. You should be getting the call in seconds, and that should be available in front of you as a result. And you got the call along with the update properly, and this is the way you can interface the GSM module. Thank you. Tutorial will clearly understand how do we interface the AT1085 with Gyro and HC05. The process is simple, and please follow the guidelines as we convey. Please go to File. That's the first step in the Arduino IDE to be followed. I'm clicking the File, Examples, and in that Arduino ISP, I click Arduino ISP, and let's check if the COM port is proper. and then upload. The Arduino ISP is uploaded, and once it is done, please come back to the file attiny_gyro_HC05. That is the file that we have written, and once you have come back to it, go to Tools, select the board attiny microcontrollers 25, 45, 85 would be there. In that you got to select the attiny 85 now. The next step is to select the internal clock frequency properly. 8 MHz is the one which is to be selected, and please select Programmer Arduino as ISP option and upload it. Once it is uploaded, the process is almost complete and we are free to go with the demo. You can see that the uploading happens right now, and once it is uploaded, you get a message as done uploading as you got right now. We'll go ahead with the demo of it right now. Please make sure all the connections are given as per the explanation that we have given you in the theoretical session. We have used a 9-volt battery for the powering up process. Please install the Bluetooth terminal HC05 if you have not done that till now, but otherwise you can use it if you have already installed it. You can see that YD_BT is displayed there. Click on it, it will get connected. And you can see that the data from the gyroscope is coming consistently on screen right now, and I'm going to tilt the board right now a little bit to see if there is a variation. You can see that when I move it here and there, the data variation is happening, and we could realize it in the screen immediately. This is how you can interface the attiny85 with gyroscope and HC05, and this could greatly help you in miniaturizing the entire task. In this exercise, we will clearly understand how do we interface the Raspberry Pi with ultrasonic sensor. The ultrasonic sensor HC05 is interfaced with Raspberry Pi, as you can see in front, and the connection details have been already explained to you. And make sure that all the connections are appropriately followed. Now, once the code is made available and burnt and executed, you will get the results in front of you. For that, open the VNC viewer and double click onto the IP address that we are seeing in front, and this will enable you to open the Raspberry Pi. And we have given the code already in the resources, and open the code, the distance ultrasonic.py. Once the code is available in front of you, you can run the code. The moment you run it, you will start getting the output, and you could see that the result is coming in front of you as 29.06 or 29.03, something like that. We have kept something at 29 centimeters, and that's what is reflected. Now we are moving it a little closer, and you can see that as we move it closer to the ultrasonic sensor, the distance is coming down. This distance measurement is what is done with the ultrasonic sensor, and we are getting accurate result when we move it closer or when we move it away. All these are real time, and you could have observed that. Now the fundamental principle is very simple. The Raspberry Pi sends 10 microseconds trigger signal to the ultrasonic sensor. The ultrasonic sensor, in response to it, immediately shoots 8 pulse sonic burst, and this travels to this interruption that we have kept in between, and it reflects back. The time that is taken for this echo to be read back by the ultrasonic sensor is communicated to the Raspberry Pi. This is how the entire calculation works. We are able to measure the distance this way. It is a simple exercise, and you can try it out yourself as well. Let's summarize. In this session, you have learned about the ultrasonic sensors and their usage. We also have seen the ultrasonic sensors available in the market for prototyping purposes. You also have learned about working of HC05 ultrasonic sound sensor and interfacing it with Raspberry Pi. Remember that if you interface ultrasonic sensor with any 5-volt operating evaluation board like Arduino Uno, you need not use the potential divider circuit between the echo pin and GPIO pins.